Hi guys, in today's lesson I'll be teaching us balancing of chemical reaction, and I know you guys wouldn't want to miss this. And if this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So let's get started with the lesson. Now, in balancing of chemical reaction, the species at the left hand side is known as what? The reactant, as this written above here. So the species at the left hand side is known as what? As the reactant. So please take note of this. The reactant, they collide and they react together as proposed by correlation theory. Correlation theory states that for a chemical reaction to occur, the reactants will have to collide together. That they have to react together for the products to be formed. So please take note of the species at the right hand side is known as what? As the products. The products are being formed when the reactant would react together. That is when they collide together as proposed by correlation theory, and the product is being what? Is being formed. So the species at the left hand side is known as the reactant, while the species at the right hand side is known as what? As the product. So please take note of this for what? For a balanced equation. Now, before we're able to balance chemical equation very well, we need to have an idea of some terms. So from here, I'll be teaching us some of the terms this is what in balancing of chemical reaction. If we don't have most of this idea, balancing of chemical equation will be a big deal to most of us. Now, the first one is what? Is the acid radical. The second one is the oxidation number, while the third one is what? Is periodic table. We need to have an idea of what oxidation number, acid radical rather, oxidation number, and periodic table. If we have an idea of these three, then balancing of chemical equation will not be a big deal to what? To us. Now let's talk about what? Acid radicals. Now, what are radicals? Radicals are a group of elements that exist as a single unit. It can be two, it can be three, but they coming together to exist as a single unit is what radical means. So I come again, radicals, they are a group of elements that exist as what? As a single unit. And of course, we have two types of radicals. So please take note of this, that we have what? Two types of radicals. We have the positive radical and the negative radical. The positive radical and what? And the negative radical. Please, you need to what? Take note of this. They are very essential in what? In balancing of chemical equation. You can't balance chemical equation perfectly well without having an understanding of what? Of radical. So like I said earlier on, I said that we have positive radical and then we have what? Negative radicals. Now, positive radical, they have positive charge, when negative radical, they have what? Negative charge. But also please take note of what? Of this. Now, example of positive radical, we have ammonium. Ammonium, which has the formula of what? NH4 plus. Like I said earlier on, the positive radical, they have what? Positive charge, while the negative radical has what? Negative charge. An example of one of a positive radical, we have what? Ammonium. The difference between ammonium and ammonia, they are not the same. Ammonium is NH4, ammonia is NH3, so they are not the same. So ammonium is an example of what? Of a positive radical. But in the course of today's teaching, our major focus will be on what? On the negative radical. Now, examples of the negative radicals include, we have PO4 3 minus, SO4 2 minus, CO3 2 minus, then we also have OH minus, we also have SO3 2 minus, then we also have NO3 minus. So these are some of the examples of what? Of negative radical. Then we also have HCO3 minus. So please take note of what? Of this radical. They are very essential in balancing of what? Of chemical equation. You cannot balance chemical equation very well, or you cannot form the species at the product side without having an idea of what? Of these radicals. So example of negative radicals include, you have PO4. The charge of PO4 is what? 3 minus. PO4 is what? Tetraoxophosphate 5. Now the charge is what? 3 minus SO4 tetraoxophosphate 6 2 minus CO3 triiosocarbonate 4 2 minus. Take note, OH hydroxide ion. So please take note of what? Of that charge. SO3 2 minus, NO3 minus, HCO3 minus. So please take note of what? Of their charge. Take note of what? Of their charge, and take note of what? Of each of these various radicals. They are used in what? In balancing of chemical equation. So but please take note of these radicals. Like I said earlier on, I said the radicals they are a group of elements that exist as a single unit. And I went further on to say that radicals are of two types. We have the positive radicals and the negative radicals. Example of positive radical, we have what? The ammonium ion, which is what? NH4. Then under the negative radicals, we have PO4 3 minus, SO4 2 minus, CO3 2 minus, OH minus, SO3 2 minus, NO3 minus, HCO3 minus. So please take note of these radicals and especially take note of their charges. Please take note of what? Of their charges. So this is all about what? About radicals. So you should please take note of this. Now, from here, let's move straight away to what? To oxidation number. Now, what is oxidation number? Oxidation number is a positive number or a negative number assigned to an atom. So please take note that oxidation number is what? Is a positive number or a negative number assigned to an atom. Some elements rather they have what? Oxidation number, because elements in group A they don't have oxidation number because their atomic shell field required 8 electrons. So some elements have what? Oxidation number. And please also take note that oxidation number can be what? Positive number and negative number, like I said earlier on. Now, I'll be using the periodic table to explain this oxidation number very well. Now, if you look at this periodic table, this is not a perfect periodic table. I just sketch out this for the purpose of what? Of examination. Please, for those of us writing the JAM examination or the WAEC examination, please take note of how to sketch periodic table like this. It's very easy. So I just sketch out this just to explain what oxidation number and periodic table itself. Now, if you look at this periodic table very well, like this is the group. Vertical line is like this, while horizontal line is like this. So please take note of that also. Now, if you look at it very well, each group, you see that each group has what? Oxidation number attached to it, except this group 8 or group 0. Group 8 is also known as group 0, whichever one you want to put. Except what? This group 0. Now, does it have what? Oxidation number. Also, please take note of what? Please take note of this. Now, if you look at group 1 happens to be what? The first group. If you look at group 1 very well, if you look at this number here, which is 1 plus, it's the oxidation number of what? Of group 1. Now, the reason why group 1 have oxidation number of 1 plus is because group 1, all elements in group 1, they have 1 electrons in their atomic shell. Now, because you have 1 electron in their atomic shell, then the oxidation number of group 1 is what? 1 plus. And please also take note of this, that mentals have what? Positive oxidation number, and non-mentals have what? Negative oxidation number. So in the course of today's teaching also, I'll be showing us mentals in the periodic table and non-mentals in the periodic table also. But please also take note of this. Please take note that group 1 element, the oxidation number is what? 1 plus. Reason because they have 1 electrons in their atomic shell. So please take note of this. Now, what about group 2? The oxidation number of group 2 is what? 2 plus. Reason because they have 2 electrons in their atomic shell. Same as what? Group 3. And please take note that all elements in group 1, group 2, and group 3 are what? Are mentals. So please take note that all elements in group 1, group 2, and group 3, they are referred to as what? Mentals. Mentals. While all elements in group 5, group 6, and group 7 are known as what? Non-mentals. Non-mentals. So please take note of this, that all elements what? In group 5, group 6, and group 7 are known as what? Non-mentals. While all elements in group 4, they are known as what? Semi-mental. Semi-mental. So please take note of this also, that all elements what? In group 4 are known as what? Semi-mental. So please take note of what? Of this also. So all elements in group 1 have oxidation number of what? 1 plus. Group 2, 2 plus. Group 3 what? 3 plus. And also please take note that all elements in group 1, group 2, and group 3 are known as what? Mentals. So please take note of this. Now, all elements in group 5, group 6, and group 7 are known as what? Non-mentals. That's the reason why the oxidation number is what? Minus. Because earlier on I said that some elements have positive oxidation number, while some elements have negative oxidation number. Now, the elements that have negative oxidation number are referred to as the non-mentals, where the elements that have positive oxidation number are referred to as what? The mentals. So please take note of the why all elements in group 4 are known as what? Semi metals. But if you come to this other group, this last group here, which is known as the group 0 or group 8, you see that this is the only group that does not have what oxidation number, because the outermost shell of this element is filled with the required 8 electrons. Normally, for an element to be stable, it needs to have what 8 electrons in its outermost shell, because that defines the stability of that element. So that's the reason why these elements in this group 8 or this group 0 does not have what oxidation number. They don't have the oxidation number because they are stable. Now, most of these elements that are having oxidation number, they are not stable. They are trying to be like this element that is stable does not have what oxidation number. So please take note of this. Now, metals, when they give out when they give out electrons in their outermost shell, they become what an ion. That's a positive ion. While non-metal, once they accept electron, they become what a negative ion. So also please take note of all these areas that I'm breaking out right now. Please, if you find this class very helpful, I want you to subscribe to my YouTube channel as Divine Online Chemistry Tutorial. Don't forget to like my video, to comment, and also to share to your loved ones and your friends. So let's continue with the lesson. So this is all about oxidation number. Please, when balancing of chemical equation, we'll be dealing more with on this oxidation number. Please have an idea of this oxidation number. Please take note of each of this group and their various oxidation number for the metals, especially for the metals and the non-metals. So please take note of this. So we have also talked about the periodic table. We talked about elements in the periodic table. We talked about metals and non-metals. We also talked about semi-metals. So these are some of the terms that we need to have an idea of before even talking about balancing of chemical equation. So from there, let's talk about the principle of balancing of chemical equation. There's a principle that governs balancing of chemical equation. Now, the principle of balancing of chemical equation states that for a chemical equation to be balanced, the number of mole of the reactant must be equal to the number of mole of the product. Because now, when balancing of chemical equation, the reactants they collide together as proposed by the correlation theory. The reactants collide together to form the product. That's the first step. Now, the next step is to check, is the moles of the reactant equal to the moles of the product? When the moles are not equal, that means that particular reaction or that you are performing is not balanced, because the mole of the reactant must be equal to the mole of the product, as proposed by the principle of balancing of chemical equation. Now, the principle states that for a chemical equation to be balanced, the number of moles of the reactant must be equal to the number of moles of the product. So we need to have an idea of this principle. This principle governs balancing of chemical equation. So should we please have an idea of this principle. Whenever you are balancing chemical equation, after you have formed the product, quickly check the moles of the reactant and the moles of the product. Once they are balanced, just know that equation is balanced. So from here, we'll be moving straight to types of chemical reaction. Any equation you are trying to balance must fall into any of this category of chemical equation that will be given or be explained to us right now. Because before you must balance a chemical equation, you must have an idea of the type of reaction that equation you are balancing falls under. Because equations fall under a specific reaction. So we need to have an idea of the specific reaction that equation falls under. Now, from here, the first reaction that we'll be talking about is combination reaction. We'll be talking about combination reaction. So we'll be talking about combination reaction. Now, in balancing of chemical equation, once they give you the reactant, because in equation like stoichiometry, calculation question like stoichiometry, they must always give you the special at the reactant side. Once they give you the special, you are being expected to form the one at the product side. Now, before you form the one at the product side, you need to have an idea of the reaction that equation you are being given falls under. So from here, we'll be talking about some of the reactions. Now, the first one is combination reaction. Now, what is combination reaction? Combination reaction is the process whereby two or more elements or smaller compound combines together to form just one single compound. So combination reaction is the process whereby two or more elements or smaller compound, they combine together as proposed by the collision theory, that the reactant will have to what collide together. So two or more elements or smaller compound, they combine together for the product to be what to be formed. Now the product is just what just a single compound. So under the combination reaction, the product is what just a single compound. So let's use an illustration. For example, A plus B will give us A, B. So this is just what combination reaction is talking about. Combination reaction is the process whereby two or more elements or smaller compound combine together and they collide together to form just one single compound at the product side. Don't forget, the one at the left hand side is known as the reactant, the one at the right hand side is known as the product. So for the product to be formed, the reactants have to react together. I seen it now. So this is what combination reaction is just what talking about. Now, having explained this, have you used illustration to explain this? And let's use elements to explain this. For example, let's say carbon plus oxygen reacting together will give us what? CO, which is what? Carbon dioxide. Are you seeing it now? So carbon plus oxygen is what is reacting together to form what? Carbon dioxide. Just one single compound is going to be formed at the product side. So this is what combination reaction is talking about. Just imagine now that under stoichiometry or under any calculation question that you are being given, just imagine that you are being given equation like this. Because they must give you spreadsheets at the reactant side. Just imagine I'll be giving equation like this. The first thing first is to form the one at the product side before you check if they are balanced. Now, once they give you something like this, the first thing that needs to come to your mind is the type of reaction that this equation they give you is falling under. Now, the first reaction is what combination reaction. Combination reaction refers to the process whereby two or more elements or compound or similar compound rather combine together to form what? To form the product. Now, once you remember that you'll be able to balance what chemical equation like this. You know that this is single element. Once they combine together to form what? Just one single compound at the right hand side. Are you seeing this now? So just imagine you are giving equation like this. You already know that this falls under what? Combination reaction. And you already know that the product to be formed at the right hand side is just a single one, a single compound. So C plus O give us CO. CO. So the first step is to form the spreadsheet at the right hand side, which happens to be what? The product. This is the first step. Now the next step is to check, is the number of mole of the reactant equal to the number of mole of the product as proposed by the principle of balancing of chemical reaction? Because the principle states that for a chemical equation to be balanced, the number of mole of the reactant must be equal to the number of mole of the product. Now, if you look at it very well, we have one carbon here. If you come to the product side, we also have one carbon. If you go to the reactant side, we have one oxygen. If you come to the product side, we have one oxygen, which means this equation is what? Is balanced. Are you seeing it now? As proposed by the balancing of chemical, as proposed by the principle of balancing of what? Of chemical reaction. So which means that this equation is what? Is balanced. So this is all combination reaction they just try to talk about when two or more simple elements or simple compound combine together to form just a single compound at the product side. So this is what combination reaction is talking about. So from here, we'll be moving to the next reaction, which talk about what? Decomposition reaction. And please take note that decomposition reaction is the inverse of what? Of combination reaction. Now, decomposition reaction is the process whereby a single compound breaks down into what? Two or more smaller compound or elements. So in decomposition reaction, a single compound, just a single compound, decomposes or breaks down to form what? To form two or more smaller elements or smaller compound. Now, what decomposes it? It is heat. It is heat that's involved that decompose the single compound to form what? Two or more smaller elements or what? Or smaller what? Compound. It is heat that brought about what? The decomposition. So what? Please take note of that. So in decomposition reaction, a single compound decomposes to form what? Two or more smaller elements or compound. So we need to have an idea of what? Of this. This is just what decomposition reaction is talking about. Now let's take an illustration to explain it. Let's say for instance, A, B decomposes to form what? A plus B. So this is what the combination reaction is talking about. It's the inverse of what? Of combination reaction. Now a single compound decomposes to form what? Two smaller compounds or what? Or elements. Now having illustrated this, now let's use elements to what? To explain this. For example, CaCO3. Now just imagine that on that calculation question you are being given, because you must just know that you must always be giving what? The special at the reactant side. Just imagine that you are being given equation like this to what? To balance, or you are working with what? This balance of, you are working what? With this pattern. Now they give you calcium trialticarbonate 4. And they said that we should balance this equation. There's an arrow here, which meaning that the one at the product side of what will be formed. Just imagine I will be giving something like this, and they tell you what? You should balance it. Now, seeing just a single compound at the reactant side, and they're telling you to form the one at the product side, the first thing that should come to your mind, what type of reaction is this equation that I'm about to balance force on that? That should be what the first question. What type of reaction that the equation I'm about to balance right now force on that? The moment you know the reaction, the moment you know the product will be formed at the right hand side. Now, for decomposition reaction, a single compound breaks down or decomposes into what? Two or more smaller compound or what? Or elements. Now you have been given a single compound here, and say that you should decompose it. You already know that two or more smaller compound or elements will be formed at the product side. It's already decomposition reaction. So now, please take note of this, that when trialticarbonate 4 decomposes, it forms, these are the products that are being formed. It forms CaO, which is calcium oxide, plus CO2, which is what? Carbon 4 oxide. These are the products that are being formed when calcium trialticarbonate 4, also known as limestone, decomposes. The product that is formed is what? It's calcium oxide, also known as quicklime, and what? Carbon 4 oxide. Those are the two products that are before what? That be formed. So in balancing of chemical equation, the first step is to what? To form the product at the right hand side. Now the next step is to check if the number of mole of the reactant equal to the number of mole of the product. That is the next step to what? To take, as proposed by what? By the principle of balancing of chemical equation. Now, if you look at it very well, at the left hand side, which are the reactant side, we have one calcium here. If you look at it, we have one calcium here. So number of mole of calcium is what? Is 1 here. Now if you come to the product side, the number of mole of calcium is what? Is still 1 here. Now what about what? Carbon? The number of mole of the carbon at the reactant side is 1. What about carbon? Okay, it's 1 here. What about carbon here? The number of mole or what? Carbon at the product side is what? It's also 1 here. Now what about oxygen? The number of mole of oxygen at the reactant side is what? Is 3. This 3 that is written as the subscript under this oxygen is telling us that the number of the oxygen atom here is what? Is 3. So oxygen here is what? Is 3. Now what about oxygen here? Oxygen here is what? Is 1. The oxygen here is what? Is 2. Are you seeing it now? This here is what? Is 1. And oxygen here is what? Is 2. Now this oxygen here that is 2 plus this oxygen here that is 1 is making it what? Is making the total number of oxygen at the product side is what? Making it what? 3. And total number of oxygen at the reactant side is what? Is 3. Are you seeing it now? So it's balanced. So one calcium at the reactant side, one calcium at the reactant side, one carbon at the calcium at the product side, then one carbon at the reactant side, one carbon at the product side, then 3 oxygen at the reactant side. We have 1 oxygen here plus 2 oxygen here, making it 3, which making the total number of also 3 oxygen at the product side. Are you seeing it now? Which means this equation is what? Is balanced, because the number of mole of the reactant is equal to the number of mole of what? Of the product. So which means that this equation is what? Is balanced. So this is all about what? Balancing of chemical equation for what? For the decomposition what? Reaction. Now from here, let's move straight away to what? To the next type of reaction that we'll be dealing with, which is what? The displacement reaction. The next reaction that we're moving straight to what? Is what? Displacement reaction. Now in displacement reaction, one element replaces another element in what? In a compound. So please take note that in displacement reaction, one element replaces another element in what? In a compound. So you should please have an idea of this. And please take note that the element that is replacing another element is more electropositive than the element that is what? That it is being replaced. So please take note of what? of that also. Now I'll be using this what to as an illustration to what to explain this displacement reaction. Now please take note that this is what a mental. This is what a mental. This is what a mental. Then this A is also what? So a mental. So a mental. Please take note that when mental and acid radical or non-mental combine together, please take note that the one first or the one at the left hand side is the mental, while the one at the last part is what is the acid radical or what the non-mental. So please take note of this. So this B is what is mental. This A is always a what a mental. Now in displacement reaction earlier on I said that what one element replaces another element what in a compound. Now if you look at this, I'm using this to explain it very well. Now if you look at this illustration very well, you will see that this B that is a mental is replacing this A that's also what that's also a mental in what in a compound. Are you seeing it now? Now when this B replaces what this A, now the product that will be formed is will not be what A plus what B Y. Are you seeing it now? Now this B is now replacing this A. So that's what displacement reaction is just what it's just talking about. So whenever you are being given equation like this, or whenever you are being given equation like this to what to balance, now please take note that this B will always what replace this A for what for the product what to be formed. Now so this is just what an illustration. Now I will brought out this. Now let's now use some compound and element what to explain this what very well. So we'll be using this to what to explain what this displacement reaction very well. Magnesium plus calcium tetraoxosulfate 6. Now just imagine that you'll be giving a reaction like this to what to balance that to form the product side. I want to balance it. Now a single mental here is combining what with mental with what an acid radical attached to it. Now once you see something like this, the first that should come to mind, this equation, what reaction does it fall under? The moment you know the reaction, then you know what the product will be formed because you know the meaning of that reaction. Now, magnesium is reacting with what? Calcium tetraoxosulfate 6. So, and in displacement reaction, I said that one element replaces what? Another element in what? In a compound. Now, having explained this, now this magnesium here is what? We replace what? This calcium. In this calcium tetraoxosulfate 6. Now the product of the form will be what? The product of the form will be what? Calcium plus magnesium SO for which is what? Magnesium what? Tetraoxosulfate 6. Now if you look at it very well, you now see that this magnesium is what? Is replacing what? This calcium in a compound, and the calcium will not be alone at the product side, while the magnesium will not combine with this acid radical, which happens to be what? Tetraoxosulfate what? 6 acid. So this is how what the product will form under what displacement reaction. Any metal you are being given here, whenever it combines with a metal with and also with an acid radical here, just know that this metal here that is alone we always what replace this metal in the compound, and then when you now replace this metal in the compound, then this metal that was the compound before will not stay alone at the product side, then this one will not combine with what with the acid radical. So that's what is happening here right now. So that's what is just happening here. So now after forming the product, the next step is to check, is this equation balanced? Is it balanced? That's the next step to what to check. That's why they call it what balancing of what of chemical equation. It's not just about to form the product, it's about is it balanced at the right hand side and at the left hand side. That's the next thing to what to check. Now magnesium, the number of atoms or the amount of more magnesium here is what is 1, because there's no figure attached to it here, or there's no figure attached to it here, so it's just what 1. So it means magnesium here is what is 1. Come to the product side, magnesium here is still what is still 1. Now what about what calcium? Calcium here is what is 1, because there's no figure attached to here, there's no figure attached to here, so calcium here is just what 1 at the reactant side. What about the product? Calcium is still what is still 1. So calcium is still what is still 1. Now go back to the reactant side. Sulfur here is what is 1. Now come to the product side. Sulfur here is still what is still 1. Now come to the reactant side. Oxygen here is what 4. This 4 that's after the subscript under this oxygen is for only the oxygen, because there's no bracket, so it's for only what the oxygen. So sulfur oxygen here is what is 1 is 4. I mean oxygen is 4. Come to the product side. oxygen here is still what? Is still 4. Now if you look at it very well, you see that the values at the right hand side and at the left hand side are what? Are equal, which means what? This particular equation is what? Is balanced. So that's the reason why they call it what? Balancing of what? Of chemical equation. So we need to have an idea of what? Of this. So from here, we'll be moving straight to what? To the next reaction, which happens to be what? Double decomposition reaction, and also the last reaction for today's lesson. Now, please, we should please let's be attentive for this very reaction, because this is the major one that I'm driving what? That I'm driving to. So let's have an idea of what? Of this reaction. Now, in double decomposition reaction, there's always exchange of what? Of radicals. Please take note that in double decomposition reaction, there's always what? An exchange of what? Of an acid radical in the product, in the reactant side, I beg your pardon. So at the reactant side, there's always what? Exchange of radicals for the what? For the product to be what? To be formed. Now let's also take an what? An illustration to what? To illustrate this double decomposition reaction. Now let's see, for example, AB plus CD. Now for the product to be formed, I said earlier on, I said that this one, the first one is always what? The metal. The first one is always what? The metal, while the second one is always what? The acid radical or no metal. So this was acid radical. Take note of that. The first one here is always what? The metal, and this was acid radical. So always please take note of what? Of this. Don't confuse them. Now in balancing of chemical equation under double decomposition reaction, there's always what? An exchange of what? Of acid radical rather in what? In the reactant side for what? For the particles on the product side what? To be formed. So the acid radical of this A will switch to the acid radical of what? Of this C. While the acid radical of this C will switch to the what? Acid radical of what? Of this A. So the product of the form will be what? AD plus CB. So this will be the product of the what? Reform. So they both exchange their what? Their acid radicals, or their non-metal rather, anyone. They both what? Exchange what? Their acid radical. So the first element here is always what? The metal, while the one here is the what? Acid radical. Same goes what? To this one. So please let's have an idea of what? Of this one. That's what happens here. Now, having illustrated this, now let's use elements and compound to what? To draft out this, so that we can what? So that we can understand very well. Now, so let's balance what? This equation. So this is a typical example of what? Of a double decomposition reaction. A metal was only a metal at the reactant side. We always have an acid radical by itself, or non-metal. A metal will always have an acid radical or a non-metal, like this. So now, whenever you are being given an equation like this, a metal is having acid radical, the other metal is having what? Acid radical or a non-metal. Just know that that equation that will be given to balance falls under double decomposition reaction, because whenever you know the reaction that is formed order, then the product will be easy for you to form and then to balance. So just imagine magnesium tetrasulfite is reacting with what? Sodium chloride. Whenever they give you an equation like this, just know that the reaction that it falls under is what? Double decomposition reaction, because there'll be what? There'll be exchange of radicals or non-metals. So the product of the form will be what? Mg Cl plus NaSO4. So this is the product of the form. There was exchange of radicals. So S of this Mg took what? Cl. So this Cl moved toward Mg, while this SO4 moved toward Na. Are you seeing it now? There was exchange of what? Radical for what? For the product what? To be formed. So this is all about what? Double decomposition reaction. Now this is the first step actually. For the product to be formed, this is the first step. Now the next step is to check, is the equation balanced? That's the next step to what? To check, or that's the next step to what? To check. Now from here, I'll be using what? I'll be using what? Oxidation numbers. So this is where oxidation numbers comes in. Please let's take note of this. That was the reason why I brought out this. So from here, I'll be using what? Oxidation number. Now if you look at magnesium very well, now which group in the periodic table does magnesium fall under? It falls under group 2. What is the oxidation number of group 2? The oxidation number of group 2 is what? 2 plus. So oxidation number of group 2 is what? 2 plus. For magnesium is what? 2 plus. Now The element close to my group is chlorine. Now, which group is chlorine? Chlorine is group 7. And the oxidation number of group 7 is what? 1 minus. 1 minus. Now, if you look at it very well, this equation is not balanced. Why? In the balance of equation, everything must be balanced, which means everything must equal 0. So everything must be balanced, which means it must equal 0. Now, if you look at this equation very well, magnesium is 2 plus, chlorine is what? 1 minus. And the balance of chemical equation, everything must equal 0. So now, for everything here, because this minus means what you are owing, and plus means you want to pay. Now, for everything to be equal 0, which means there's no change, or which means you are not owing, we need to have another atom of chlorine here. Because we only have one chlorine here, we need to have another atom of chlorine here. When we have another atom of chlorine here, it now means that chlorine is now what? Is now 2 here. Because Cl2 means that we have 2 atoms of chlorine here, which is Cl and another Cl. Now, if we put 2 here, it means that we have 1 minus before, and then we have what? Another 1 minus. Now, 1 minus 1 minus is equal to what? 2 minus. So look at it very well. So 1 minus 1 minus is equal to what? 2 minus. Now, 2 plus 2 minus is equal to what? 2 plus 2 minus is equal to what? Is equal to what? 0. Are you seeing now? Which means this place is what? Is balanced. Now, let's go to the what? The right hand side, to the reactant side rather. Now, chlorine here is what? Is 2. Now, what about the chlorine at the reactant side? Chlorine here is 1, is just 1. Are you seeing now? For the fact that there's no 2 added here, just mean that chlorine here is just what? Is just 1. Which means everything must equal. If it's 2 here, it will also be 2 at the reactant side. But before we move to the reactant side, let's quickly complete the one that is here. Now, SO4 is an acid radical. Now, what's the charge of what? SO4? SO4 is what? 2 minus. Please take note of that what? SO4 is what? Is 2 minus. I gave acid radical earlier on. Please take note of them and their charges. Now, SO4 is what? 2 minus. Look at it very well. Then what about sodium, which is the mental? Which group is sodium? Sodium is what? Is the group 1. Which means the oxidation number of group 1 is what? 1 plus. So oxidation number of group 1 is what? 1 plus. Now, like I said earlier on, minus means you are owing and plus means you want to pay. Now, 2 minus means you are owing 2. 1 plus means you have 1. If you pay, you still be having, you still be holding 1. Now, for every and balance of chemical equation, I said that everything must equal 0, which means everything must balance. Now, for everything to be balanced here, for everything to what? To be balanced here, we need to introduce another atom of sodium here. Because we only have 1 atom of sodium here. We need to now introduce another atom of sodium here, which means sodium will not be what? 2. Which means plus 1 and another what? Okay, which means 1 plus another what? 1 plus again. Because if you put 2 here, it means sodium is what? Is now 2 yen. 1 sodium and another sodium again. Is now what? 2 yen. Because the charge of sodium before is what? 1 plus. Because there's 2 here, it now means that the charge will not be what? 1 plus and another what? 1 plus. Making what? Equals to, making what? 2 plus. Now, 2 plus 2 minus is equal to what? It's equal to 0. Because you're already someone with 2 naira and you have 2 naira to pay. It means that everything is what? It's balanced. So everything is what? Equals 0. So it will not be what? Na2SO what? SO4. Because SO4, the charge of SO4 is an acid radical and the charge is what? 2 minus. And the charge of sodium is what? 1 plus. Now for it to be balanced, we now have to introduce another atom of sodium here to now make it what? Na2. Which means 1 plus 1 plus equals to what? 2 plus. Then 2 plus 2 minus is equal to what? 0. Which means this place is what? Is balanced. Now, we now have MgCl2 plus Na2SO4 as our product. Now, sodium, the number of atoms of sodium at our product side is what? Is 2. But if you come to our reactant side, the number of atoms of sodium is what? Is 1. And if you come to our product side, the number of chlorine is what? Is 2. And if you go to our reactant side, it is what? It is just 1. Now, which means we have to make everything what? Everything balanced. Which means sodium here will be what? 2. And chlorine here will also be what? Will also be 2. For everything to be what? To be balanced. Now, please take note of this. That because chlorine here will have to be 2 and because sodium here will have to be 2, does it mean that we have to put 2 like this? We'll put 2 here like this and put 2 here like this. Now, because the number of mole of the two of them is just 2 and 2, then if you want to put the 2, you put 2 as a mole at the front here like this. So the 2 will be as a mole, which means you clean this 2. So the two will be what as a mole at the front of what sodium and at the front of what of chlorine. Now this two is showing that sodium here is 2 and chlorine here is 2. So we have 2 atoms of sodium here and then we have 2 atoms of what of chlorine here. Now if you come to the product side, sodium is what is 2 here, chlorine is what is 2 here. Are you seeing it now? So that's just it. Now what about what for the magnesium tetraoxide? Now SO4 is what 2 minus. And then how many atoms of SO4 do we have yet? 1. How many atoms of SO4 do we have what? 1. Now magnesium is what? Magnesium is how many atoms of magnesium do you have here? 1. How many atoms of magnesium do you have here? 1 is balanced. But we need to check for their what? For their charge first. Now SO4 is what? 2 minus. Now what about magnesium? Which group is magnesium? Magnesium is in what? Group 2. The oxidation number of group 2 is what? 2 plus. So magnesium is what? 2 plus. And the balance of chemical equation, everything must equal 0. Everything must what? Equal 0. Now 2 plus 2 minus is equal 0. Minus means you're OD. 2 minus means you're only 2 naira. 2 plus means you want to pay. Now, you are only someone with 2 naira, you have 2 naira. Once you pay, everything is what equals 0 because it's balanced. Everything is what equals 0. So magnesium 2 plus SO4 2 minus equals what 0, which means here is what is balanced. You don't need to add figures to what to it again because it's just what is balanced. So we have 1 atom of magnesium here, we have 1 atom of magnesium here. SO for 1 atom here, SO for 1 atom here. What about chlorine and sodium? Now these two is showing that chlorine is 2 atoms. We have 2 atoms of chlorine here and you have 2 atoms of sodium here. And then if you look at these two at this chlorine side, it means that 2 atoms of chlorine is here and 2 atoms of what sodium is what is also here, making it balanced. So this is all about what balancing of chemical equation using of what opposition number. So this is all about what balancing of chemical equation.